Hello everyone. Um, Today's lecture is homogeneity of variances. Um, in the previous week, we performed the hypothesis testing for making comparison between two means, either dependent or independent. Remember, the independent means we were supposing that the variances are equal or not equal. So we perform two different tests depending on the variances. So if you have a suspicion on the variances of the assumption, so what you need to do, you can test it whether the variances are equal. If they are equal, just use the equally variance assumption to make a comparison and use the pooled variance to test um, the two means. But if they're not equal, then you need to use the other one, calculating the different degree of freedom. It was completely different. Okay, let's get started. The testing homogeneity of variances. Today we're gonna first try to test the variances for two different populations. So we have variances from samples, and we're trying to figure out whether there is a difference between two variances. It means what you're looking for is whether the sigma 1 square equals to sigma 2 square. That's for the population 2. The variance of the first population variance equals to the second population variance. This is you just try to construct the hypothesis in this case as not equal. That's how you construct the null hypothesis is, okay, sigma 1 square equals sigma 2 square. H1 is sigma 1 square is not equal to sigma 2 square. And you don't have a left-sided and right-sided hypothesis, only double-sided two-tailed hypothesis. And if you're trying to test this hypothesis with alpha level, you can't use the alpha level itself. So the alpha level is split into half, and use alpha divided by 2 to test this. The thing is, for this hypothesis, we're not using the t distribution table or the standard normal distribution table anymore. What we do is we're using f test. The f distribution test is not a symmetric, and it is left tail distribution. It is skewed distribution. So the picture of the f distribution, depending on the degree of freedom, I'm gonna drawing you a picture, approximately one picture representation. It looks like this way. It's like it has a right tail. I said left tail, I'm sorry. It's the right tail distribution, but it depends on the degree of freedom. The F distribution does not have a single degree of freedom. It has 2 degree of freedom, one for the numerator part of the distribution and one the denominator part. So you have 2 degree of freedom. So the table value, we have many table values. I only try to have 4 of them, and I will have all those 4 tables within my lecture notes. In the end of the lecture note, let me show you here. So the F table for 0.10, you have 1 degree of freedom. df1 and df2, and df2 is a representation in the columns and degree of freedom 1 from the rows, and this is for 0.10, and this is one table, and I try to fit two tables within a single page. And if you change the alpha level, so the F statistics will increase. Let's see. See that this is 161.45 and this one is 39. So the first one is 39. So it's increasing for the as much as you decrease the alpha level, the value will increase. Okay, look at the next one. So 0.01, even the critical value will increase a lot for the first one. This is just an example, and I also have this is 0.001, and it is really a extremely large value. The critical values will increase as the alpha level is decreasing. Okay, so you have many tables, so you can increase the table value, say more than probably 10 of them, 10 table you can increase, but those critical values fine, we mostly use those critical values and no need to have another table anymore. I present you those tables. So the infinity here, you have an infinity, the degree of freedom. Inf is a representation of the infinity. 120. So you don't have all sequentially up after 30. And you skip to 40, 60, 120, and infinity. So the difference is not very much after 30. So you can in place of 31 you can use 30, or in place of 70 you can use 120 or 60. That's fine because they are very close to critical value. It won't have any effect on the rejection of the null hypothesis. Okay, let's go back to the lecture notes. So this is a comparison of two variances and checking that whether two populations are homogeneous or whether it is heterogeneous. If you reject the null hypothesis, so you will think that the variances are heterogeneous, or otherwise they are homogeneous. If they are homogeneous, you use this information for the comparison of two independent sample means, and use the pooled variance, a single degree of freedom, and 1 plus and 2 minus 2 will be okay. If they are heterogeneous, and use the second one to present a single degree of a degree of freedom, it is obtained by a calculation, and you wouldn't need for the pooled variance. The reason why we try to have in fact homogeneity in the variances is that, like, let me give you an example from real life. If you want to make a comparison between two different prices, let's say 1 kilogram of an apple and 1 kilogram of a banana, and you wouldn't know which one is more expensive, you can't make a comparison, so you have no idea because they are different, the measurements are different. But if I ask you something else, and this time you will answer me the answer easily. If I tell you that whether 1 kilo banana, which one is more expensive, 1 kilogram of banana or 2 kilograms of banana, you will easily say that 2 kilograms of banana is more expensive. But you wouldn't really make a comparison of the price of 1 kilogram of banana and 1 kilogram of an apple. They are both different, and so it means they are heterogeneous. And the other case is they are homogeneous, both are bananas, and you can tell about the main price. You will tell that 2 kilograms of banana is larger than 1 kilogram of banana. So this is like you rescale two of them and tell that there are two banana, and I can make a comparison of the mean. So this is why we definitely need to know about the variances, whether they are homogeneous. If they are heterogeneous, okay, there is a way we have shown you calculating the degree of freedom. but it is not very powerful test. So it is better to have the variances to be homogeneous, especially for a comparison of two independent samples. Okay, to perform such hypothesis, we use the F calculated statistics, which is F calc equals S. In place of a subscript 1, I'm gonna have a maximum variance that's divided by the minimum variance. Okay, the reason I'm saying maximum, actually the large one should go to on the numerator part, and the small variance should go to on the denominator part of the F calculated statistics. So if sigma 1 square is larger than sigma 2 square, sigma S1 square will be on the numerator part, and then S2 square will go directly to on the denominator part. So it depends on the large value should go on the top, and the bottom on the division should go the smaller variance. So it does not necessarily mean that you need to use homogeneity of variance for two population. You could have more than two groups of population, even if you have more than two groups. You can use that statistics. All you need to have the maximum variance on the top, on the bottom you have the minimum variance. So if you have more than two population variance, let's say sigma, okay, if you want to test this hypothesis, sigma 1 square equals sigma 2 square equals, okay, sigma square k different groups. H1 is this time you don't really have the alternative hypothesis to be sigma 1 square is not equal sigma 2 square is not equal. This is not true, really. Indeed, that's not true. I wouldn't construct the alternative in this way. What I do, I'm gonna delete this because it's not true. I don't want to have it in my lecture note this way. So the construction of the alternative, when you have k groups of population to make a comparison between k different population variances, so what you do is you write at least one population variance is different from the rest. So if you reject the null hypothesis, you're supporting one of the population variance may differ from the others. Even if one is different, so it means homogeneity is not satisfied anymore. It is the variances are heterogeneous. One is different. It means the reason is one is different. Okay, you can use the same statistics, F calculate statistics. So this is the simplest statistics you can use for checking whether there is a homogeneity among the variances. There are some other statistics as well. It's called Levene statistics. It is a bit harder. It is the calculation takes really time. No need to know by hand. This is the simplest one you can use. But if you use a statistics software, you can use Levene statistics. This is available in statistical packages for social science. SPSS Levene test statistics and Bartlett test statistics are other statistics you may use for checking homogeneity. Okay. The Levene test and the Bartlett test, the calculation takes really time. So use SPSS or let's say SAS or R project for such test. Okay, they are available on those statistical packages, statistical software. You can use, but if you use the statistical software, you don't have the calculate. You're not dealing with the calculated statistic. You represented the p-value. You check whether the p-value is less than the given significance level. If it is less, it means they are heterogeneous. If it is greater than the significant value, you will conclude that the variances are homogeneous. Okay. This is the basic statistics, the F-calc statistics. So if F calculated statistics is less than greater than F, you have 2 degree of freedom, df1, df2, and alpha divided by 2. If this condition is satisfied, then we conclude that the variances are not equal. The variances are not equal. Okay, degree of freedom, df1 is and the sample size of the great variance, the large variance, so I'm gonna have it as maximum minus 1. So it doesn't mean the greater sample size. Don't be confused about this symbol. The n max is the maximum variance. So the maximum is not a large sample size. So df is the n max minus 1, whereas df2 is n minimum minus 1. That's the second degree of freedom. Let's have an example. I have probably a nice example within the book. I'm gonna copy the example, prepare the example in here. Okay, I should have it here. Let's see. Okay, there is the example and it has the solution as well, so I'm gonna skip the solution, only have the example. Okay, right here. Okay, let's go back to my lecture note, my teaching place. Okay, right here. Okay, maybe I could avoid writing the example in here. Delete all this stuff here, no need, because I have a title for the example within the picture I passed here. So okay, fine, right here. Okay, this is the example. Okay, example. Okay, fine. A sample of 9 technicians, let me read you this example, exposed to the standard version of a training film required an average of 31.4 minutes to service a compressor system with a standard deviation of 14.5 minutes. For 7 technicians viewing an alternative version of the film, the average time required was 22.3 minutes with a standard deviation of 10.2 minutes. If the sampled population are approximately normally distributed, can sigma 1 square and sigma 2 square be assumed to be equal? Okay, the underlying data I don't have it because I don't have the book, and the book has a special data set within probably a CD file, a CD compact disc. No need, because everything is given and that's fine. The calculation will be fine, easily. We can perform the calculation easily here. Okay, let me change the color of the pen here. Okay, the null hypothesis will be sigma 1 square equals sigma 2 square, and the alternative sigma 1 square is not equal to sigma 2 square. So the alpha level is not given, so you can use either the 0.05, the universal one is 0.05, and let's use all of them. Let's consider alpha 0.05, alpha equals 0.01, the alpha equals 0.10, or let's say the alpha level 0.001. Okay, if you split alpha into half, I don't have the table value for 0.025. This is tough. But if you use the alpha level for to be 0.10, in this case, you can split it into half. I have the alpha level to be 0.05. And this is the problem in this test statistics, because you don't have all the table values. It is very difficult. You need to have many of them to check whether the test statistics is significant. Okay, let's write the given for the test statistics. So S1, an average of temperature, the standard deviation for the first one, S1 equals 14.5. This is not the variance, this is the standard deviation. And N, let's see, N1 is 9 technicians, 9 of them. S2, the standard deviation for 2 is given as 10.2 and N2 is 7. Okay, in this case, this is maximum, this is larger. Since it is larger, so S1 is S maximum. So this is smaller, since this one is smaller, so S2 is S minimum. Okay, let's get the calculated statistics. F calculated equals S1 square will be divided by S2 square. For another example, if you use another example, you may have S2 square divided by S1 square. So this is because the S1 square is the maximum, S square maximum, and divided by S square minimum. Okay, let's get this value. Calculated statistics is 14.5 square, that's divided by 10.2 square. Okay, let's write the result. I'm gonna use my mobile calculator to get this done for you. Okay, 14.5 square, 14.5 square divided by 10.2 square. The result is 2.0209. I'm using 4 digits, rounded. The last digit was 8573. I rounded to 9. Okay, if I use the alpha level, 0.10, I'm not going to look for the critical value from 0.10 F table. What I'm doing is I'm going to split alpha level into half and get this level of significance. So it's going to be 0.10, that's divided by 2, and the new alpha level is 0.05. All right. Okay, if I use this value and the critical value, F critical, will be equal to F 9 minus 1, 7 minus 1, and the alpha level 0.05. This is from the table. If I go to the table I prepared for you, this is the first table. I skipped this table, I don't need that. I need the 0.05. Okay, the degree of freedom, the first degree of freedom is 9 minus 1 becomes 8. So I'm going to look for the row 8. This is the row I'm interested. Okay, and 7 minus 1 becomes 6. So this value is the value I'm interested. Okay, that's the value. Okay, 3.5801. So 8, the degree of freedom. See that this is 8. 8 here. And and 6. Okay, so I need to look for 8 and 6, the degree of freedom. See that here. 8 and 6, 0.05, which is 3.58 something. Let me see again. See it again. Yes, this is 58.06. This is 58.06. Okay, and the calculated statistics is smaller than this value. The F calculated statistics, which is 2.0209, is less than 3.5806, and then we think that the variances are equal. So this is our conclusion. Of course, the alpha level is 10%. We have an error. Let me draw you a picture for the F distribution. Okay, let's say that this is approximately that shape. I'm gonna read this. Okay, and the critical value is 3.58, somewhere here. Let's say here. Okay, that's the rejection area. This is a rejection part. This is 0.05 because we split the alpha level. Even if the alternative hypothesis is double-sided, we do not use we do not have two rejection region, only one rejection region on the right side. So you don't have on the left side. So this is the whole is accept region. That's the accept region, and this is 0.95. Because I'm not using the alpha level, the whole alpha level 0.10, I split it into half and have a single rejection part on the right side of the graphical representation of F distribution. Okay, in this case, our statistics, let me change this color. This is black, the black, and the calculated statistics, I'm gonna have it red, just to show you that this is not falling within the rejection part, and the calculated statistics is simply falling within the rejection region, which is 2.0209. So this is the rejection part. I'm gonna highlight this for you. Okay, fine, right here. Okay, that's the rejection part. So it's simply falling within the acceptance region, the accept region. You accept the null hypothesis, and the null hypothesis is a representation of the homogeneity. Since the calculated statistics F statistics is falling within the accept region, we do not reject the null hypothesis. And conclude that the variances are homogeneous. Okay. If you increase, if you, decrease the level of significance, and you'll see that this is the rejection part in here, and it will move to this side. If you decrease the level of significance, it will move further, and you will always accept the null hypothesis and conclude that there is homogeneity. But in our case in here, the critical value, I need to have it in here, 3.5806. Yes. Okay, let's see what the book is presenting for you. I'm gonna presenting you the way how the book is looking at the subject of the homogeneity of variance. So this is my teaching, and I'm gonna share with you the content of the book. It may be useful for you. Reading is will be nice for you. So just try to read all this stuff in here. I found it very useful. Let's copy this stuff here. Have it within your lecture note. Okay, go back to your lecture notes. I'm not sure whether if I can fit it in here. Hopefully I will fit it. Okay. Yeah, maybe. Okay, just fine. Okay, a little bit more. That's fine. That's it. Move it up a bit. This is how the book is taking the comparing the variances of two independent sample, it says. But in practice, you can use this way. This calculates statistics for more than even two independent samples. You just picking up the large value on the top and have the bottom one, the small one on the bottom. Okay. See that what does the book tells that HO is sigma 1 square equals sigma 2 square, and the alternative is the same as my case. And the alpha level, according to the book, there are 3 different tables, but I presented you 4 of them. Even the book only have 3 of them. I present you 4 of them. And the calculation F statistics is this one, and it tells you that pick the large one. So you pick the large one. That's what it tells you in the book. So it tells you that to pick the large one. So it means to pick the large one means on the denominator part you should have the maximum variance. So it is the same. And in the book it presents you the alpha level on first. I don't prefer this representation. I prefer this is in the end. I prefer the degree of freedom comes first. And it tells you that the degree of freedom for the first one n minus 1, where n is the size of the sample that had the larger variance. So this is the same as what I do in my calculation, and this is the test statistics, the same. So let's see the solution from the book, presenting you the solution as well. So here you go, and I need to present you this as well, the 5 and 6. I like to have this within your lecture note. I like it here. Okay, here you go, have it in our lecture notes. Let's have it right here. This is the old one. Okay, go back to, it seems that the copying is not successful. Go back here, make my selection. Okay, copy, go back to my lecture notes, have it right here, find right here. Okay, so 5 and 6. So if the degree of freedom v1 or v2 happens to be one of the larger value not included in the table, you can interpolate between the listed entries. The decision rule is reject the null hypothesis if the calculated F statistics is larger than the critical F, otherwise do not reject. So this is what I also taught you here. Compare the calculated and the critical values and reach a conclusion. If the calculated F exceed the critical F, we are not able to assume that the population variances are equal. And make the related decision. This will depend on the purpose of the test. For example, if the variance for one investment portfolio strategy differs significantly from the variance for another, we may wish to pursue the one for which the variance is lower. The ability to assume equal variances would also allow us to compare two sample means with the pooled variances t-test of section in the book, section 11.2. However, keep in mind that the unequal variances t-test, we already told, for unequal variances can routinely be applied without having to go through the inconvenience of the test for variance equality. So it means if you are not sure about the variances and you have no information about the homogeneity, and you perform this such test, the F test, and decide in the end whether your the populations are homogeneous. If they are homogeneous, you calculate the pooled variance, and the t statistic is different. And if they are somehow heterogeneous, and you should use the other test for unequal variances for the two independent sample. Remember, from 2 weeks or 3 weeks ago, we studied such hypothesis testing. So this is useful for the t-test, comparing two sample means as well, and it is also useful, very useful, in making a comparison more than two sample means. If they are heterogeneous, you're not able to use the ANOVA testing, which is the next subject in the week 10. I'm going to study the ANOVA, analysis of variances, making a comparison more than two sample means. It will be the next subject. If they are equal homogeneous, you can easily use the F statistics, the F ANOVA analysis. That will be fine. The coming week will be related to the homogeneity, the comparison of more than two groups of means. Let's see let me have you the result of the example according to the book, how the book take the solution. This is the solution for the book, according to the book, so it should be very similar to mine, no difference, shouldn't be that difference. Okay, let me have it within your lecture notes. I'm gonna share the lecture notes as well from the lapses. You can find the lecture notes as well. And now we're having a WhatsApp group as well. I'm gonna share the lecture notes from there as well, sharing you this link once I upload this video into YouTube, and you can also, you're able to watch all this teaching as well. So the solution, look at the solution. The book is considered the alpha level to be 0.02, and we can also consider O for 0.02, and I consider only for 0.10, and I split into half. It will becomes 0.05. I have for 0.05, I have the critical value according to the book. Okay, see that this is 2.02, which is the same as ours, and the critical value, see that this is 7 and 6. The first degree of freedom will be 7, and the second is 6. See that the F statistics, when you calculate the F statistic, trying to have the large value, on the top, on the denominator part, and the small variance should go on the bottom division. Okay, if you consider the alpha level, okay, the alpha level according to the book is taken to be 0.02, which is unusual alpha level, but splitting alpha into half becomes 0.01, which is available table values. This is available one. For 0.01, table becomes 8.10. And if I go to my table values for 0.10, 0.01, this is 0.05. According to the book, this is the table used in the book. So you should go to nominate the degree of freedom, which is going to be 8. Okay, and you should go here to 6. So the intersection is for 0.01 is 6.371. Okay. Okay, 6.371. Okay. Okay, this one. Come with here. Alright. Having trouble here a bit. I'm gonna delete it. Let's delete this stuff here. No need for this. And this is the first. I think I made a mistake in the beginning as well in the solution, because the degree of freedom, the first degree of freedom, is not coming on the rows. It comes on the columns. So this is a mistake even in the previous, in my solution. I will fix it. So the degree of freedom will be 8. For the top degree of freedom should go here. I'm confused about this. I'm really sorry about that. I'm gonna have a circle. 8, and should go here 6. Okay, so it's going to be 8.3 So this one is 8.02. Okay, that's table shape. Okay, this is a degree of freedom. In the previous one, I made a mistake in my case. So 8 should go, I'm gonna move this one in here. So I'm not going to use 6. Okay, delete this. Let's delete this. So I'm gonna use 8 here. Okay. Okay, 8. So 6 should go here. Okay. So this is the value I should be interested. So this time I made a mistake in here. I'm fixing this problem here. Sorry about that. So that's the degree of freedom, the critical value 4.1468. I'm gonna fix this for you. In my case, this is going to be okay. That's not true. 4. This is 4.1406, I guess. E1468. I'm sorry about that. Gonna fix this for you. 68. This is 68. So I'm gonna fix everywhere. This is not true. That's not true. This is going to be 4.1468, and even the comparison here is incorrect here. I fix it, but the conclusion won't change at all. It is true. 4.1468. Yes. Okay. If I use the alpha level 0.10, I split it into half, 0.05, I do not reject the null hypothesis. According to the book, it is the same, but the alpha level is different because the book is picking up for 0.01, as I showed you in here. The third table is presenting, this is for 0.01. According to the book, this is 0.01, the degree of freedom, the level of significance. So you're picking, this is 8.102, so approximately 8.1. Okay, let's see if whether there is another example exercise. And this is a good picture, and the decision, the comments are very nice. So I want you to have all this result in here from the book as well. You can read all this and make a comparison between my comments and the book comments, so they should be parallel, no difference at all, no different at all. Okay, I'm gonna have it right here beneath this in here, right here. Okay, so let me enlarge this picture for you as much as I can, and this is readable now. You can read it. So the critical value is 0.01 alpha divided by 2 in here. See that, the rejection part. So the critical value is 8.10, and the calculated statistics is falling within the accept region if equals 2.02, and the decision, see that the decision you make this, the population standard deviation could be assumed to be equal, and it would be permissible to apply the pooled variance t-test for making a comparison between two independent sample means. And let's see whether there is another example or exercises in the book. If there is, I'm going to have it in here within your lecture note. You study yourself this basic hypothesis testing for homogeneity of variances. So this is the book, and the calculation is also performed within Minitab or Excel, that's statistics software. So those are the exercises you can study yourself. I think it is very simple. It's very simple subject comparing variances. Only you divide the maximum, the minimum divided by the maximum. So it is very simple. I'm gonna copy all this stuff here. I like you to have it within your lecture notes. Okay, fine, copy. So you study yourself those exercises. You will find it very useful. Please do so. Study the exercise. Enlarge it here. Okay. All right. Today's lecture is over. This is the end, and you will have, this is the end of lecture 9. You will have my lecture notes as a PDF file within the LabSys, within DYS system of the university. And also I'm gonna share all these lecture notes within the WhatsApp group we have constructed just today by Doğukan, one of my students, Doğukan. And I shall see you later in the week 9 lecture 10, sorry. And have a nice day, and keep safe, stay safe, and stay away from the coronavirus, and take care of yourself, and bye for now.